So this is a key for the stoichiometry problem 65 from chapter 3 in our book. First thing, A, it asks you for the molar mass of chloral hydrate. Tells you there's 2 carbons, 3 hydrogens, 3 Cl, and 2 O2. Molar mass should be easy. We went over in class. This represents carbon. That's the mass of hydrogen. This is going to represent the mass of chlorine and oxygen from the periodic table. They're using the one in the book, so their rounding is going to be a little different. So keep that in mind. So the answer just has to be close, not exact. So when you go, if you look, 12.01, notice how they take it 3 decimal places. So your number is going to be a little bit off. So anywhere around 165.4 would be good. 2 times 12 is going to be 2402. 3 times that is going to be roughly 3 plus 3 of those plus 32 there. You should be right around 165.4. They're going to use that calculated value, the 165.39, in all the book problems. So keep in mind, you just want your number to be close. It doesn't have to be exact. Okay, what are the amount of moles in 500 grams of chloral hydrate? We start with a grid every time. So we set up a grid. First thing I'm going to do is I'm going to drop in 500.0 grams of C2H3Cl3O2. I know that grams has to go down here based on what we did. So C2H3Cl3O2. We said the value was 165.4. 165.4 equals 1 mole of the same thing, C2H3Cl3O2. Fluffy bunny, I cancel. That's the units of my answer. All I have to do is take 500 divided by 165. Grams to mole conversion, very simple in chemistry. This is right from the book key. Notice they're carrying it farther. It's going to be 4 significant figures. So if your mass is off, this will be off. It just has to be close. Keep that in mind. What is the mass of that many moles of chloral hydrate? Same thing. We always start with a grid in these problems. So we're going to grid it up. Then what we're going to do is we're going to drop in the 2.0 times 10 to the negative second moles of chloral hydrate, which was what? C2H3, okay. C2H3Cl2O2 goes there. Well, if we have moles there, moles of that means, Fluffy Bunny, moles of C2H3Cl3O2 goes there. Coefficient's 1 because we're using molar mass. We said the molar mass is about 165.4 grams of C2H3Cl3O2. I got my units. Fluffy Bunny cancels. So all I'm doing is multiplying 2.02 times 10 to the negative second. This starts with 2 sig figs. Units of my answer is going to be grams of chloral hydrate. And if we take a look, multiply it across, I get 2 significant figures. It should be right around 3.3. That's part C. D, how many chlorine atoms are there? We talked about this in class. If I have C2H3Cl3O2, they're asking me to just identify a piece of it, not the whole thing. What you're going to do is you're going to go to Avogadro's number, and then you bust out the ratio, because one of these contains 3 Cl. So I'm going to go 5.0 grams of C2H3Cl3O2. Molar mass is 165.4 grams. C2H3Cl3O2 equals 1 mole of, I'll just write CH for chloral hydrate because I'm getting tired. Yeah, right. 1 mole of chloral hydrate is equal to 6.02 times 10 to the 23rd. And see how it's all nonmetals? So I'm going to write the word molecules. It's just the label. It's not that big of a deal. Now, I go to Avogadro's number. If I stop there, Fluffy Bunny, I have molecules of chloral hydrate. I want to know chlorine atoms, so I'm zooming inside. There's only one of these when I zoom inside, so what do I say? 1 molecule of C2H3Cl3O2 is equal to 3 atoms of Cl. I just add I'm adding the ratio from the compound whenever they ask me to go inside. If it's not the whole enchilada, you zoom in, you focus on that. When you go to do the actual calculation, you put there's your molar mass times that, 1 to 3 ratio. We're going to round to 2 significant figures based on the given. So you're going to be 5.5 times 10 to the 22nd. That's how you do that one. What mass would contain 1 gram of chlorine? So it's the same idea. We start with 1 gram of chlorine. That means when I go to do this, I have to start here with grams of chlorine. We know off the periodic table it's 35.45 is the mass of chlorine is equal to 1 mole of chlorine. What do we know goes on the bottom? Moles of chlorine has to go on the bottom. Well, what do we know? From here, we knew if we went back here, 3 of these equals 1 molecule. So what we would do is we would go here, 3 moles of Cl, right from the formula, equals 1 mole of C2H3Cl2O2. Now I have moles. It's asking me mass, moles here, 1 mole of C2H3Cl3O2 equals here is going to be, we said 165.4 grams, I believe, of C2H3Cl2O2. And I'm going to just run my grid. 2 significant figures. When I go and look, 2 significant figures, I get 2 significant figures. Fluffy, bunny, fluffy, bunny, fluffy, bunny. The only thing I'm left with is the mass. My units pop over, and that's how it's done. 500 molecules. Molecules of chloral hydrate, the whole thing. So when we go to set it up as a grid, we set it up like this. We're going to set it up as a grid, and what we're going to do is we're going to drop 500 molecules here. Whatever the label is dictates what you do next. If I have molecules here, I have to have molecules down there. The only label or the only conversion factor that has it is 6.02 times 10 to the 23rd, and that's going to be molecules, goes right there, equals 1 mole of C2H3Cl2O2. So now I've gone from molecules to moles. Now I can get mass. 1 mole of C2H3Cl3O2 is equal to 165.4 grams of C2H3Cl3O2. Fluffy bunny. Molecules is gone. Moles is gone. I'm ready to rock and roll. I just dropped 2 conversion factors in, and I'm good to go. Boom. Molecules cancels. Moles cancels. Grams is my answer. In this case, wow, the sig figs are wrong. What the heck? Where did they get that from? Well, that's an example of the book key being sketchy. Technically, that has 1 significant figure. That's odd. They gave it 4. Wow. I don't even know where that came from. If we even did 3, let's say 3 significant figures, we'll say 1.37 times 10 to the negative 19th grams is what you would get. And that basically is basic stoichiometry. Without, the key thing is there's no chemical equations. So whenever you have something like this, there's no chemical equations. That means it's basically going to be grid driven and you don't have to worry about balancing. The next part of chemistry is balancing equations. All right?